Welcome to Barishal Cadet College and good morning to you all. Hope you all are fine at your home. Dear cadets, you have to follow the preventive tips for your safety. Wash hands with water and soap or sanitizer at least 20 seconds. Avoid contact with sick people. Don't touch eyes, nose or mouth with unwashed hands. Don't eat raw foods, thoroughly cook meat and eggs. Avoid contact with animals and animal product. Due to corona pandemic, our regular classes are not taking place. So now I am here to take your class virtually. I am Abu Said, lecturer, Department of Mathematics, Borishal Cadet College. In this class, I am going to discuss probability from chapter 10b of your book, Learning Outcome. After the class, you will be able to explain random experiment, mutually exclusive event, independent event, dependent events, prove and apply the laws of addition of probability, apply laws of multiplication, solve probability related problem. Now, sample space. A sample space is a set of all possible results or outcomes of a random experiment. Suppose if we have thrown a dice randomly, then the sample space for this experiment will be all possible outcomes of throwing a dice, such as sample space is equal to 1, 2, 3, 4, 5, 6. If we throw a dice, then the sample space is 1, 2, 3, 4, 5, 6. This is sample space. Now, a random experiment. An experiment whose result cannot be predicted until it is noticed is called the random experiment. For example, when we throw a dice randomly, the result is uncertain to us. We can get only output between 1 to 6. Hence, this experiment is random because previously we don't know what will be happen. Now, random variables. The variables which denote the possible outcomes of random experiment are called random variables. They are of two types: discrete random variables, continuous random variables. Now, discrete random variables take only those discrete values which are countable, and the continuous random variables could take infinite number of possible values. Now, mutually exclusive event. It cannot happen at the same time. Example, this is one event and this is another event. Two events are not happened at the same time. Ace and kings are mutually exclusive, cannot be both. Now another example of mutually exclusive event. Turning left and turning right are mutually exclusive. You cannot do both at the same time. When you go left and turning right are mutually exclusive because two events are not happen same time. Now another example, tossing a coin. When you toss a coin, heads and tails are mutually exclusive because heads and tails are not happen at the same times. Cards. Kings and ace are mutually exclusive. You see here. But mutually exclusive event, the probability of A or B is the sum of the individual probabilities. That means P A or B is equal to P of A plus P of B. That means the probability of A or B equals the probability of A plus the probability of B. You know, probability is equal to favorable number of cases divided total number of cases. Now, addition law of probability statement: the probability of the happening of any one of two mutually exclusive events is the sum of their separate probabilities. Let S be the sample space associated with the random experiment and A and B be two mutually exclusive events of S. We get P of A union B equal to P of A plus P of B. This is addition law of probability of mutually exclusive event. P of A union B is equal to P of A plus P of B, or we can write here P of A or B is equal to P of A plus P of B. Now, not mutually exclusive event. Not mutually exclusive event means they have at least one common sample point. And mutually exclusive event, there are no common point. Here, at least one common point, common sample point. Example, if A equal to 1, 3, 5 and B is equal to 3, 6, here 3 is the common sample point of both these two. That's why these events are not mutually exclusive. Now let's see what happens when events are not mutually exclusive. Here you see in the figure, here this is the common point of these two hearts and kings. Here this is the common point. Hearts and kings are not mutually exclusive, can be both are common here. Hearts and kings together is only the kings of hearts. These but are common. That's why these events are not mutually exclusive. Not mutually exclusive event, the formula is P of A or B is equal to P of A plus P of B minus P of A and B. We can read this formula is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. In the another way, we can write this formula is P of A union B. Here OR means union and N means intersection. That means we can write P of A union B is equal to P of A plus P of B minus P of A intersection B. This true formula we use when we solve probability related questions. Now, independent events. Independent events. Two events are said to be independent events if their probability of one event that does not affect the probability of another event. That means two events are independent. If two events are mutually exclusive, they are not independent. Also, independent events cannot be mutually exclusive. Remember these things. Two events are mutually exclusive. They are not independent. Also, independent events cannot be mutually exclusive. Events can be independent, meaning each event is not affected by the another. Again, I repeat, events can be independent, meaning each event is not affected by the other events. This is an important idea. A coin does not know what is come up heads before its toss of a coin is a perfect isolated thing. If we toss a coin, so a coin does not know that's come up heads before or tail before. This is 50-50 chance. Then that's why this event is two events are independent. They are not dependent to each other. Note that two events A and B are independent if and only if P of A intersection B is equal to P of A into P of B. We use this formula when we solve probability independent event related probability problems. Remember this formula. This is the important formula. This formula is also known as multiplication formula of probability. Now, dependent events. Two events are said to be dependent if the occurrence of one event changes the probability of another event. That means one event depends another events. But events cannot be dependent, which means they can be affected by the previous events. Example, marbles in a bag. 2 blue and 3 red marbles are in a bag. What are the chances of getting blue marble? The chance is 2 in 5. Here 3 red marbles and 2 blue marbles. What happens? Let's see. After taking one out, the chances change. So the next time, after taking one out, if you got red marbles before, then the chance of the blue marbles next is 2 in 4. That means 4, 2 in 4. If we got blue marbles before, then the chance of the blue marbles next in 1 in 4. So the next event depends on what happened in the previous event and is called dependent event. Again, I repeat this term. If we got red marbles before, then the chance of blue marble is next is 2 in 4. If we got blue marbles before, then the chance of blue marbles next is 1 in 4. So the next event depends on what happened in the previous event and is called dependent event. Here P of A means probability of event A. In our marble example, event A is get blue marbles first with the probability of 2 by 5. That means P of A is equal to 2 by 5. And event B is get blue marbles second, but for what we have two choices. If we got blue marble first, then the chance is now 1 by 4. If we got red marble first, then the chance 2 by 4. Now P of B condition A. This symbol we use condition. Here P of B condition A means event B given event A. In other words, event A has already happened. Here event A has already happened. Now what is chance to event B? P of B condition A is also called the conditional probability of B given A. Conditional probability means A event has already happened. And what happened is B. And in our case, P of B condition A is 1 by 4. So the probability of getting two blue marble ball is, if we got one blue balls, then the probability 2 by 5. Here, if we putting one blue balls, then the probability is 1 by 4, this way. Now, conditional probability. P of B condition A, that means is equal to P of A and B by P of A. In other words, we can write P of A intersection B by P of A. Here, P of A already happened. Now, later, the probability of event B given event A equals the probability of event A and event B divided by the probability of event A. Now, let us clear these things by example. 70% of our friends like chocolate and 35% like chocolate and strawberry. What percent of those who likes chocolate also like strawberry? So here given what percent of those who likes chocolate, this event is already happened. Now we find what percentage of people are like strawberry. Now P of strawberry condition chocolate, that means probability of chocolate and strawberry divided probability of chocolate. Here given that P of A means P of chocolate is equal to 70%, that means 0.7, and in the both P of A intersection B or P of A and B is 35%, that means 0.35. So 50% of our friends who like chocolate also like strawberry. This is the conditional probability. And we write a formula P of A and B is equal to P of A into P of B condition A. That means probability of event A and event B equals the probability of event A and event B equals the probability of event A times the probability of event B given event A. Now we use this formula. Let us try to solve some questions. Here given that if P of A is equal to half and P of B is equal to 3 by 5 and A and B are independent, that means, and find P of A union B. So solution, given that P of A is equal to half, P of B is equal to 3 by 5, and P of A union B is equal to what? Here given that A and B are independent, we know if two events are independent, so we can write P of A intersection B is equal to P of A into P of B. Now putting the value of P of A and P of B here, then we get P of A intersection B. Also, we know P of A union B is equal to P of A plus P of B minus P of A intersection B. Now putting this value here, P of A, P of B, and P of A intersection B here, then we can write P of A is equal to half, P of B is equal to 3 by 5, and P of A intersection B is equal to 3 by 10. After calculating this, we can write 8 by 10, that means 4 by 5. This is our required answer. Now another question. What is the probability that Ram will choose a marble at random and that it is not black of the ball contain 3 red, 2 black and 5 green marbles. So our total ball 5 plus 2 plus 3, that means 10. And red and greens, 5 plus 3, that means 8. Find the number of marbles that are not black. Now find the number of marbles that are not black and divide it by the total numbers of marbles. So we can write probability of not black is equal to number of red or green marbles divided total number of marbles. Here total number of marbles 10 and number of red and green marbles 8. So the probability of not black is 8 by 10. This is our required answer. Now another question. If P of A intersection B is equal to 1 by 3, P of A union B is equal to 5 by 6, and P of A is equal to half, then find the value of P of B and P of B complement. Solution. Given that P of A intersection B is equal to 1 by 3, P of A union B is equal to 5 by 6, and P of A is equal to half. We know P of A union B is equal to P of A plus P of B minus P of A intersection B. Now putting this value here P of A union B is equal to 5 by 6, and P of A is equal to half, and P of A intersection B equal to 1 by 3. So P of B is equal to, we can write 5 by 6 minus half plus 1 by 3. That means 2 by 3. We know complement, that means P of B complement, that means 1 minus P of B. That's why we can write P of B complement is equal to 1 minus P of B. Here P of B is equal to 2 by 3. Now putting this value here, then P of B complement is equal to 1 by 3. Now another question. The probability of a student of passing in Bangla is 2 by 3, and that both in Bangla and mathematics is 14 by 45, and that is any one subject is 4 by 5. What is the probability of his passing in mathematics? Solution. Given that P of B is equal to 2 by 3, that means the probability of passing in Bangla is 2 by 3, and passing both Bangla and mathematics is 14 by 45, and any one subject, that means P of B union M, that means Bangla or mathematics, is 4 by 5. We know P of B union M, B means Bangla, M means mathematics, is equal to P of B plus P of M minus P of B intersection M, or P of B union M is equal to 4 by 5 is equal to P of B means 2 by 3 and plus P of M minus 14 by 45. So P of M, we can write P of M is equal to 4 by 5 minus 2 by 3 plus 14 by 45. That means 20 by 45. So the probability of passing in mathematics is 20 by 45. That means 4 by 9. Now another question. If a number from 10 to 30 is selected at random, what is the probability of its being a prime number or a multiple of 5? Solution. Let S be the set of numbers. So we can write NS is equal to 30 minus 10 plus 1. That means 21. And the second condition is being prime number. And third condition is multiple of 5. So let A be the set of prime numbers. That's why we can write A is equal to 10 to 30. That means 11, 13, 17, 19, 23, 29. These are the prime numbers of 10 to 30. So we can write n of A is equal to 1, 2, 3, 4, 5, 6, 6, and B with a set of multiple of 5. Here 10 to 30, multiple of 5 is equal to 10, 15, 20, 25, 30. So we can write n of B is equal to 1, 2, 3, 4, 5. 5. Though A and B are mutually exclusive, that's why we can write the probability of the number B prime or multiple of 5 is P of A union B is equal to P of A plus P of B. From the definition of probability, we can write P of A is equal to N of A by Ns, and P of B is equal to N of B by Ns, because we know the definition of probability is the number of favorable outcomes divided the total number of outcomes. Here total number is 21 and the favorable outcomes is 6 prime number when prime numbers is 6 and when multiples of 5 is 5. That's why we can write n of A by n of S plus n of B by n of S. Now putting this value n of A n of equal to 6 and n of S is equal to 21 and n of B is equal to 5, n of S is equal to 21. After calculating this, we can write 11 by 21. This is our required answer. Now another question. One pot contains 2 white and 3 black balls, and another pot contains 3 white and 4 black balls. One ball is drawn from each pot. Find the probability of the balls of same color or different color. Now solution. Here total number of balls in first pot 2 plus 3, that means 5. In the second pot 3 plus 4, that means 7. Let the first pot drawing a white ball is W1 and the black ball is B1. And the second pot, first ball is W2 and the second ball is black ball is B2. That means white means W and black means B. That's why let the white ball is W1 and W2 and black balls is B1 and B2 from the first pot and second pot. So we can write P of W1 is equal to 2 by 5, because here given that the first pot white balls 2 and the total ball is 5. So the probability of P of W1 is equal to 2 by 5, and the black ball, when black ball, the probability is 3 by 5. In the same way, in the second pot, when the probability of white, that means 3 by 7, and black is 4 by 7. That's why we can write P of W1 is equal to 2 by 5, and P of B1 is equal to 3 by 5, and P of W2 is equal to 3 by 7, and P of B2 is equal to 4 by 7. Now, first question. Probability of 2 balls be the same colors. Probability of 2 balls be the same color. That means probability of W1 intersection W2 plus probability of B1 intersection B2. 2 balls are same color. Here 2 balls are same color. Now putting this value, 2 events are independent. That's why we can write P of W1 into P of W2. Here P of B1 into P of B2. Now putting this value here, P of W1 means 2 by 5 and P of W2 means 3 by 7. And P of B1 means 3 by 5 into 4 by 7. After calculating this, we can write 18 by 35. Now probability of two balls be the different color. That means if one color is white, so another color is black. That's why you can write probability of P of W1 intersection B2 plus P of B1 intersection W2. Two events are independent. That's why we can write P of W1 into P of B2 plus P of B1 into P of W2. Now putting this value here, 2 by 5 into 4 by 5 plus 3 by 5 into 3 by 7, because P of W1 is equal to 2 by 5 and to P of B2 is equal to 4 by 7. After calculating this, we can write 8 by 35 plus 9 by 35. After calculating, we can write 17 by 35. Now another question. The probability of alums failing in Bengali is 1 by 5, and that of passing in Bangla and English is 3 by 4, and that of passing in any one subject is 7 by 8. Find the probability of his passing only in English. You remember this here, this word only in English. That's why. Solution. The probability of alum failing in Bangla is 1 by 5. So the probability of passing in Bangla is 1 minus 1 by 5. That means 4 by 5. Let the event of passing in Bangla B and event of passing in English E. Then P of B is equal to 4 by 5 and P of B intersection E. That means passing in Bangla and English is 3 by 4 and passing in anyone is B of B union E is 7 by 8. Now P of B union E is equal to P of B plus P of B minus P of B intersection E. Now putting this value here, then we can write P of B union E is equal to 7 by 8. P of B means 4 by 5. P of B minus P of B intersection E is equal to 3 by 4. So P of E is equal to 7 by 8 minus 4 by 5 plus 3 by 4. After calculating this, we can write 33 by 40. This now probability of his passing only in English is equal to P of E minus P of B of intersection E. Only, that's why you can write P of E minus P of B intersection E. Now putting this below here, P of E means 33 by 40. P of B intersection E is equal to minus 3 by 4. After calculating this, we can write 3 by 40. Now this is your homework. If P of A intersection B is equal to 2 by 3, P of A union B equal to 5 by 6, and P of B is equal to 1 by 7, then find the value of P of A and P of A complement. If P of A is equal to 2 by 5 and P of B is equal to 3 by 7 and A and B are independent, then find P of A union B. A ticket from same kind of 20 tickets in a box writing 1 to 20 is selected at random. Find the probability of its being multiple of 3 or 5. This is your homework. That's all for today. If you have any query, you can ask that in the comment section. Lastly, I would like to remind you the most important thing in this critical situation. You must stay home and keep yourself safe. Stay fine. Thank you.